Hello and welcome to another free code session. My name is Jason Bach and I'm staring at stuff. The more I look at how this code really works, it's interesting. So what do I mean by that? First of all, I didn't take this into consideration, okay, which is if you, or more to the point, this is if the line number, if we do have this update line thing here, the first number could be negative. So we have to handle it like the unary one we just did that was fixed. So if I go to the evaluator, okay, and I come down here, what I need to do is do the same thing I did here, okay, which is I get the line number, okay, and then the line to update, whoops, is the one on the left. Okay. And then we do this. Okay. And now the count is sort of this, where we say we need to get the value. Yeah. Because if I remember right, let's come up here. Let me read this again. Expression evaluates to a positive integer as instructions for the line that number to the to-do list. So line may appear times because of this, each expression which evaluates to a negative integer. As instruction remove the line with the absolute value of the number from the to-do list. Nothing happens. Multiple line numbers may be specified separate by commas. To specify the same number many times, the shorthand notation used. The number of times they remove may be an expression which evaluates an integer. A negative number of times corresponds to changing the sign of the line number. Okay, that just... Wait a minute. This is where all this stuff like really throws me, because they have an example down here which is literally showing -7, 100, but the number of times to add or remove may be an expression with evaluation integer. A negative number of times corresponds to changing the sign of the line number, and 0 does nothing. So what do you do if the line number is negative? Like, yeah, so what did I actually do here with 7? So I just assume that if you do that, so what would happen if you had -7 and -100? What overrides what? I guess, okay, so coming back up here, okay. We need to get both the line number and the count. And all we do is we say, I'll just call this something else for right now, is if the line number is greater than 0, then we simply just take what the count was. Okay. If the line number is less than 0, we minus the count. A 0 would do what? I guess in this case, if it's greater than or equal to 0, we would do that. Does that make sense up here too? Having a line number of 0, you know, there's no formal description of what all these should do. It's kind of just wing it. But I do believe this is correct. Okay, what are you barking at? Oh, else. Oh, yeah, duh. I'm being stupid. There. And then bring that back. Okay. So this actually I guess I could, yeah, I could just do this. Shove it in there like that. Okay. All right, so we get the line number. We get the line to update, which is the absolute value of it. The count is what's on the right. If the line number is greater than equal to 0, we just simply take what the count was, if it's minus or not. Otherwise, we reverse the sign on the count. Okay, so that takes care of that. I think that's, I'll just run the test, but I don't really have any tests on the evaluator, so. The next one should be fun. I'm going to do a simple one. Hopefully that's simple. Famous last words. So if I come back to here and I do the execution actions, one of them is n. Okay, n will basically print out the number of, I think it's the number of times the n takes an integer argument and returns the number of times that line number is in the current to-do list. Yes. Okay. So let's support an n. I think that's up here. Conversion expression. This is also something that we're going to have to be addressing because conversions are going to be fun. Okay. So a call instruction. We need a built-in function called n. It's a great one, isn't it? N. Parameter takes the line number and returns that. That's all it does. Okay? If the call function is equal to n, then we do actions.n, passing in that, because we should have had one argument. Right? Right. Yes, yes. That's all it should take. So it's just a simple call. So if I run this and I say 1 print the string of n of 1, I say run 1. Reset. If I do 1, 2, we could say 1 print string of n of 2, and then we can do 2 minus 1, run. So we should sometimes get 1, and we sometimes won't. Yep, it depends on the... Okay, so that's cool. So we just supported n. That was pretty simple. And we probably could do the same thing for u, although I don't see any... but that's pretty much the same thing, right? Which is we take in a number. Now this one's a little more interesting, okay? Because I've been using big integers everywhere. But u takes an integer argument and returns a string containing the Unicode character with that Unicode number. Okay. So what I could do because I like things ordered. I can't do that at the top of my head. Okay, so we can say u, which is a u. It will take a integer. Doesn't matter, but it's going to return a string, right? the thing here, though, is that if we get a u, oops. If we get a u, now we need to call u, but we're going to cast this to a long, because u needs to take a long. It can't take a big integer, because reasons. It actually should technically take, now that I think about it, oh, you're wonderful. Yeah, Unicode, no. Yeah. There is no way to... So what is u actually doing underneath the scenes? What do I have it doing? Is the real question. No. Unless I'm reading this wrong. Yeah, that's different. The unit, I do that wrong. It takes an integer argument and returns a string containing the Unicode character with that Unicode number. So, what we really should do here is be consistent in that the u is going to take, because everything is a big integer, okay? We're going to take a big integer here as well. But what we really want to do is say, we want to get a char here, right? Convert from Unicode point. That's exactly what we want. But what we need to do now is convert the number that we get to an int. There we go. I think that's correct. Yeah, I believe so. So then here in our evaluator, we don't have to do any real nasty stuff. We can just say big integer. Oops. And that's it. So we do un, and then, so now if I run this, if I say 1 print, and I don't have to do a conversion here, u of 44, it's the comma? Sure. Is that? I say 1 print of the u of 65. Run. It's an A. Okay, so I believe that's correct now too. So we've got u supported. And we actually fixed a bug. Added call to u and fixed the bug. Okay, so those were the easy ones. And I don't know if, I definitely know I'm not going to finish the episode figuring this out. This is kind of going to be talking about what do I really do here? Okay. What I'm getting at is, if I come back to the Fibonacci sequence generator, and I come up to this, when I pass in again, okay, if I look at the documentation, the against statement takes a Boolean argument. If the argument is true, statement is executed, argument is false. This is not a Boolean argument, okay? So, what you're really doing here is And defer. Yeah, so it says statement here, but it's really statements. Okay. And I wonder if I'm really doing this right, which is because I think we're really not doing anything with again. It's a bool, and we're just saying, do it again. I think this is actually the way I have it implemented here is completely wrong. Because it's saying again takes a Boolean argument. If the argument is true, the statement is executed but remains in the to-do list. You execute it again sometime later. If the argument is false, the statement is executed and removed from the to-do list as normal. So I don't think I'm doing this right. I don't even think I'm doing anything. I mean, I think again is doing the right thing, which is, returning the right value, but I'm not doing anything with it, which is absolutely wrong. So the way I'm coding this in these little generator things is not correct. Because the defer is saying if you so what do I actually do in the again? Should statement be kept? Oh, that. Right, execute actually, okay, that's what I'm doing. I think I'm doing this right. These are just the lines. Well, current line count is greater than 0, we just keep. That's right. You execute in both spots, but it only matters when you determine if you should remove it from the list or not. Which is what we're, that's what the again does. Okay, so I think I'm doing this right. I think. Which is it just simply determines whether you should keep it or not. And then every time you go through it, when you finally finish the list, then it will determine if you should increment the count of it or not. Okay. So that is correct. That makes sense, because I wrote these to test, does this actually do the thing I think it should do? So I think these are correct. So I got to convince myself, yes, Jason, you are okay. Here's the problem. Is, for example, in this case with defer, you'll notice that there is a 3 in there. But you can't OR that with this, so you can't OR that with this. Okay. And since the n is just simply the number, right? Yeah, it just gives you the count of the number. You can do a comparison to that. The problem becomes is when I'm passing in like a number here to again, or a defer here to again. Now you could just say, well, why don't you turn that for again like into a number? But it's possible you could be passing in something more to again. What do I mean by that? I don't know what I mean by that. Again, if I come back up here again, is a Boolean. It's not a number. So if I come back to this, what I'm saying here is I need to convert that to a Boolean. But what I really need to do is determine, does that line actually exist? That's what there's a hidden call, for lack of a better term here, to say if it is a number, and what I'm expecting in this call is a Boolean, then what I need to do is convert it to a does line exist. Okay. Now, what about in cases like defer here. This is just a unary value, and I'm doing an OR on it. Okay. So what am I actually doing here? What I need to do is convert it into a does line exist, but I don't do it for this case. Okay. So unary value, or I should say literal numbers, values here, the context of where they are in the call is important. I could be explicit to say, well, what you should really be calling is a does line exist, a DLE on it. And, you know, that would actually be, I think, more correct. You know, but in the spirit of the way that the spec is, should I leave it this way? And this is where I'm not going to have an answer to the end of this episode. This is something I'm going to have to debate in my head. I got to get a workout in, eat some lunch, and then think about this some more. Maybe, and again, the whole idea of just letting something go, just thinking about it, letting my brain think about what this actually needs to do. Because, again, the position of where this value is important. And this only exists for things like in defer or again. When you call, for example, N or U, those are expecting a line number. Those are expecting a a line number for both N and U. Those are integers. For defer and again, if you find a spot where you're trying to do a number to a Boolean, you can't just call does line exist on it. Because, for example, like a greater than or a less than, you would simply take the number as is. But if you're trying to do a or like a pipe or a ampersand, then you have to sneak in a call to does line exist on those. And I can't report that as an error. That's the other thing. So if I remember it, I think somewhere in the parsing code or somewhere in the binder, it looks at this and says, well, you have a number on one side and a Boolean on the other. That's not good. But I have to, no pun intended, defer until I actually determine its context, which is if it's in a call to defer, and again, it shouldn't matter, like if this or this or this, like if I stuck this in the middle or if I stuck this at the end, it wouldn't matter. Okay. So somewhere within that, I have to determine that it's okay to do that. You just need to call does line exist, which returns a Boolean, and then it will bind correctly. Okay, so that's something I have to, I think the operators here need to defer their determination of, like the binary operator has to say, well, yeah, a Boolean and a integer, there is no conversion to this. Now, if you're doing a greater than, but there is like greater than or less than, there is no, those have to be numbers. There is no like true is greater than false. That doesn't exist. So in those cases, So it's really, okay, this is where I'm starting to think this out. It's really only when you're doing I wonder if the rule is, if you just find a floating number and you're trying to do a Boolean comparison on a binary operator, that you actually need to call does line exist on it. That's what you're really doing. Mathematical operations, you don't. Only on these Boolean ones would you do that. So I think what I'm getting at here is, because I want to get these notes down, for which operations would those be? Let's see. If I come into so it's in the star and slash, plus and minus, equals equals these tokens. Less than no. No. And a pipe token. I believe that's correct. If one of the, either the left side or the right side, and or the right side is a number, then we need to actually do an implicit, do a call to does line exist. So I think I'm almost there. So when we parse this, when we find the binary expression, if it's one of these and you see one of those as a number, then you're basically saying to convert it to a Boolean. In that place, you're doing a does line exist. And so you're going to turn that into a call expression. I think that's it, but I'm out of time, so I may come back to this later today or tomorrow. I'm getting really close to tax time, and I've just been, ironically, deferring it. I need to get that done this weekend, which shouldn't take too long. You know, it's busy paperwork, more or less. So, of course, I've cursed myself when I said that, but we'll see. But I think I've got this solved now in my head. I just now need to actually implement it. And then if I do, what should just flow out of it then is a call to again and defer should just work. Should. That's the... There is a little... I know I'm babbling, but there's a little bit of... work here, because like in the Fibonacci, when you call again, you notice that it's just a call. But if I call defer, that's dependent on everything. Like everything after it depends upon defer. Nothing after again depends upon it. It's just a marker in the engine to say, do we do the right thing? Defer actually says everything after it depends upon what's called on defer. So if we need to do a call and defer, then we need to say everything after that line, after that in the line, we will only do something with it. Like we still need to bind and evaluate everything to it, but we only do that if the result of defer was actually to do that. So I have to think about that in my head. So I'm going to stop right now. Thank you all for watching. Leave comments and questions below. See you in the next episode.